What is the difference between a wormhole and a black hole? What is antimatter, and why does the Enterprise need it? Are time loops really possible? And can I kill my grandmother before I am born? Discover the answer to these and many other fascinating questions as a renowned physicist and dedicated trekker explores the physics of Star Trek. Today's science fiction is often tomorrow's science fact. The physics that underlies Star Trek is surely worth investigating. To confine our attention to terrestrial matters would be to limit the human spirit. From the foreword by Stephen Hawking. The dedication. To my family. But I cannot change the laws of physics, Captain. Scotty to Kirk, innumerable times. Foreword, Stephen Hawking. I was very pleased that Data decided to call Newton, Einstein, and me for a game of poker aboard the Enterprise. Here was my chance to turn the tables on the two great men of gravity, particularly Einstein, who didn't believe in chance or in God playing dice. Unfortunately, I never collected my winnings because the game had to be abandoned on account of a red alert. I contacted Paramount Studios afterward to cash in my chips, but they didn't know the exchange rate. Science fiction like Star Trek is not only good fun, but it also serves a serious purpose, that of expanding the human imagination. We may not yet be able to boldly go where no man or woman has gone before, but at least we can do it in the mind. We can explore how the human spirit might respond to future developments in science, and we can speculate on what those developments might be. There is a two-way trade between science fiction and science. Science fiction suggests ideas that scientists incorporate into their theories. But sometimes science turns up notions that are stranger than any science fiction. Black holes are an example, greatly assisted by the inspired name that the physicist John Archibald Wheeler gave them. Had they continued with their original names of frozen stars or gravitationally completely collapsed objects, there wouldn't have been half so much written about them. One thing that Star Trek and other science fiction have focused attention on is travel faster than light. Indeed, it is absolutely essential to Star Trek's storyline. If the Enterprise were restricted to flying just under the speed of light, it might seem to the crew that the round trip to the center of the galaxy took only a few years, but 80,000 years would have elapsed on Earth before the spaceship's return. So much for going back to see your family. Fortunately, Einstein's general theory of relativity allows the possibility for a way around this difficulty. One might be able to warp space-time and create a shortcut between the places one wanted to visit. Although there are problems of negative energy, it seems that such warping might be within our capabilities in the future. There has not been much serious scientific research along these lines, however, partly, I think, because it sounds too much like science fiction. One of the consequences of rapid interstellar travel would be that one could also travel back in time. Imagine the outcry about the waste of taxpayers' money if it were known that the National Science Foundation were supporting research on time travel. For this reason, scientists working in this field have to disguise their real interest by using technical terms like closed time-like curves that are code for time travel. Nevertheless, today's science fiction is often tomorrow's science fact. The physics that underlies Star Trek is surely worth investigating. To confine our attention to terrestrial matters would be to limit the human spirit. Preface. Why the physics of Star Trek? Gene Roddenberry.
To keep listening to this audiobook for free, click the link in the description. It will take you to a free Audible trial where you can listen to this and many other books for free for 30 days.